Hello, everybody. My name's Ashton. I manage the commercial operations here at ZIVA. I want to start off by thanking everyone for joining us today. I know this is a very highly requested topic, so for many of you, this is your first ever Live with ZIVA webinar. There's also a lot of people in the room today that have been here at every single live webinar session, and we really appreciate that. And today, as everyone knows, we are going to be covering the fundamentals of anatomy warping. These are tools that are in 1.4 right now, so this is something that you should all be able to leverage very quickly. And as usual, we will be posting this video onto the ZIVA resources section. So if you need to go back and rewatch anything, I'll have it posted within the next day or two. And of course, you can always share it with anybody else who you think would appreciate it. But yeah, I'll let you go from there, Andy.
Awesome. Hi everyone, Andy Van Straten here, Creature TD, ZIVA Dynamics. I think there's some sirens going past. So today's topic, as Ashton was saying, is about anatomy warping. It's kind of an interesting concept with ZIVA that you can kind of leverage the work that you've done on other characters. So if you're creating a new character, you don't have to start completely from scratch, which is a kind of a powerful concept. So I thought I would try and illustrate that for you guys today. Yesterday I prepared a secondary character. The idea was that I would grab a model from the internet and then try and transfer everything from the Mr. Ink setup to it. So this is the dude we got. So you can hide that. It's like a cave troll guy from Turbo Squid. It's kind of like a bit of a headbanger. And I wanted to call him Mr. Orc, but Ashton thought that Gus would be better, so he's called Gus. And so today I'm going to be transferring the stuff over to Gus. So to do it, the first thing you're going to need is 2 meshes with point correspondence. So you're going to need 2 meshes with the same topology that differ spatially. So if I bring in, I've already prepared those 2 meshes, and at the end of today's webinar, because I want to kind of focus mostly on the ZIVA specific stuff today, and then at the end, if there's time, I can go back and look at how you can use RAP3 or something like that to get the point correspondence. So, oops, just go back here and then grab some models. So we have the Mr. Ink skin, which is this mesh here. And we're going to bring in the projected. Move some of this stuff, got the zoom stuff in the way. Okay. So can toggle the visibility on these guys. And I'll just select them so you can see. So the key thing to remember is when you make this when you project the skin of your first character onto the skin of the second character, you do have to really think about things like where the elbow is. So if you have, if this vertex on the original represents the elbow, that's got to be in the same. It's also got to be the elbow of the secondary character. Do you know what I mean? So when you come to do your warp, it's gonna stretch things all in the right proportions, or shrink. So the other thing to note is that you'll notice that these are closed volumes. It's really important that they're closed volumes, because that way you can guarantee that the whole mesh is populated with tetrahedra. And because the approach that we're going to use today is called embedding, which requires it's going to require that all the meshes that we warp, all the anatomy, are going to all the points are going to fall within at least one, or they're going to fall within one tetrahedron. So if you don't have a closed volume, ZIVA is only going to tetrahedralize the boundary. So the stuff that's right in the middle, there's no guarantee, especially when you get to smaller tet sizes, there's no guarantee that that some of your points are going to fall within a tetrahedron, so you won't get a good warp. So that's why it's important that it's a closed volume. Okay, Cool. So I'm just going to get rid of these namespaces here. I know there's a new way of doing this, but I don't know what it is. Right. So I'm going to call this the from mesh. I'm going to call this the to mesh. And what's going to happen is, for the first step, I'm going to just do the bones. I'm not going to do the muscles. The line of action stuff present. There's no ZIVA stuff on any of these objects. There's no bones or tissues or anything like that. It's just the geometry with the rivets and the corresponding line of action curves. And so the idea is that when you do the warp, all this stuff comes along the ride. You don't have to kind of attach all your rivets and line of action. So that'll only work if you're using this approach using rivets. I know not everybody does that, but it's just worth showing anyway. So yeah. So I'm actually going to duplicate the from mesh. I'm going to rename it actually. So we'll call this from tissue, and we'll call this from bone. Cool. So what's going to happen now is I'm going to convert the tissue to a tissue. And do that. And I'm going to just hide this stuff now, right? First thing I'm going to do is make the tets finer. So let's try a value of 10 here for the start. And in the material, I'm going to turn off Poisson's ratio, because Poisson's ratio is describing volume conservation, and we're not so interested in that for what we're doing today, because we're going to be artificially changing the volume. So we don't want to, we don't really want ZIVA to be thinking about that too much. Cool. So the other thing I'll do is switch off gravity. So we don't care about that. I'm going to add an extra sub-step just to boost the solve quality. And I'm also going to add a cache, just so we can scrub and see our results. Cool. So I'll hide that for now, and then I'm going to turn the from bone into a ZIVA bone. And then I'm going to create a blend shape from the to mesh to the from bone. So what's going to happen is, over, say, 10 frames here, it's going to slowly, the from bone is slowly going to transition into the shape of Gus. So, and then what's going to happen is we'll make an attachment so the tissue comes along for the ride. So we'll get that set up first. So if I select the to mesh first, then the from bone, and then under rigging, deform, create blend shape. And I'm just going to key that target. Okay, that looks good. And now I have to create an attachment between the tissue and the bone. So you can do that. I'm going to use a goal attachment. It probably won't make much difference for this particular one, but a goal attachment will ensure that the attachment gets made with the corresponding vertex ID, but these meshes are right on top of each other anyway, so it's neither here nor there. Cool, so now when I play this back, you can see that the tissue follows along, it's cached so you can scrub it. Hide the other stuff if you like. Cool. So that's that part done. And now what we need to do is we need to embed our inputs, let's call these bones, within the tissue. So it's probably going to be easier if I move that up there. So I think from memory you have to have the tissue, if you to do it by hand, you have to have the tissue selected first, then the static mesh. And so ZIVA, under the ZIVA menu, if I come down to add tissue property, I think it is, you can select embedded mesh, and now the humerus bone is going to move the object, right? So that's how that works. We don't want to be going through them all individually. So a small script here somewhere. I think, yeah. Let's grab it out of my utilities thing. Cool, so it's going to take a list of meshes. It's going to look at the mesh list. The first object is going to be the tissue and then embed everything else. And, okay, so select the tissue first. And then we already did that one. So down here, hopefully this will work. I need to pass it the current selection. Cool. And now, hide that. You're going to see the whole anatomy warp as the blend shape comes on. So this is all pretty cool. This gets us like a lot of the way there. I think probably what we're looking at is, well, for at least for the results that I did, which I can show in a second, I didn't do too much tweaking to the bones. You can see that there is a little bit of buckling in here. There's some down here. Some of this is already in the model, I think, from the previous one, because Mr. Ink was warped from something else. So there's that. And then there's a bit in the humerus as well. So at this point, once you've done the warp, I mean, you can do other things as well. Like if you don't like it, if you want it to be higher fidelity, for instance, you can make the tet size lower. You can change this to say 5, or you could make the goal attachment weaker, so it's trying less. It's more of a general warp. Yeah. So there's a few parameters that you can play with there, which is just the regular, ZIVA VFX parameters. It's probably worth mentioning that, we do want to make this process easier for people. So this is very much what you can do with ZIVA VFX today. So it's not, just want to be clear that I'm not presenting this as a perfect solution, because it can't do things like warp transforms yet. You can only warp, or you can only embed meshes into a tissue currently. So yeah, it's probably worth playing around with the parameters, the solve parameters, just to see what you can get until you get a result that you're happy with. Obviously you want to think about anatomical principles. Like I would say this femur bone, for instance, is not really the right shape here. So, and a lot of that I think was already in the model, but what I would do from here is duplicate this group and then do any sculpting at this level. So if I was to sculpt this, I'd probably do like grab tools, quite good, I think. Oops. Yeah. And turn that off. Do this sort of thing. The other thing I think I had to be aware of with this one was that if we bring back the 2 mesh, I'll make it a template so you can see through it. I think from the model, the model's kind of telling us that the kneecap should be lower. So you might have to do something like I think what I did was I grabbed these and I made a lattice. So rigging, deform, lattice. And then I just kind of, I don't know, I think I made a few more points and pulled that down a bit. So that's the kind of thing you can do. And I purposely made a duplicate and edited the duplicate because once you've done your sculpting, you probably don't want to do that to both sides, right? You want to mirror these over and then rename them. And then you can do a blend shape back to your originals. And then that way you keep all your line of action stuff. So yeah. Once you have the skeleton geometry, I'll just refer to my notes here. yeah, once you have a skeleton geometry that you're happy with, then you can go back, I think, and do the joint hierarchy. So at this point, I can show you where I got to with this guy. So I took the martial arts animation from Mr. Ink and did all the warping and stuff, and then this is kind of where I got to. So this is probably, I probably should have shown this earlier, but it gives you an idea of what you can get out of one day of work. So yeah, I put this all together completely yesterday, and honestly, I spent most of the time getting the bone rig over. The actual ZIVA portion of it, warping the geometry and then copying the setup across was not that long. That was a couple of hours. I probably spent 2 hours doing a double knee setup on the leg, which is a complete waste of time. I didn't need to do that. Yeah, so because we don't really know how studios are driving their bone rigs, and that's kind of by design, I'll probably leave that portion out of it for today's webinar. But one thing that you can use that might be helpful is if you're warping, if you want to try and warp across transforms, you can do something like, for this, I could create a cube for every single joint and snap it to the pivot point. And then I can run the same process as I ran before with the, where was that? With the bone warping. So instead of the skeleton geometry, I would have a bunch of cubes that I'd be warping across. And then from there, you can get the centroid of the warped cubes and snap the joint hierarchy to it. You have to be careful of which order you do that in. So you have to, first you have to do the root and then walk down the leg and do it that way. So your script has to at least recursively walk through. But that's one way you can quickly do the joint hierarchy. And then, but that's only one part, right? You've probably got secondary or tertiary rigs on top of that. So I think for me, what I did was I did the warping, like I said, of the joint hierarchy, and then I kind of snapped the Mr. Ink rig to this. So the secondary rig sort of came along for the ride somewhat. But then again, the leg it wasn't stretchy and things like that, so it didn't quite work. But that's an idea for you in terms of doing that process. And then once you have your warped joint hierarchy, then you need to get motion on it. So that's what I used Kinema to do that. So what you're seeing here is, yeah, there's quite a lot of regular TD, non-ZIVA TD work that's gone into it. So yeah, and today, for the rest of the day, I'll just try and talk about the ZIVA specific stuff. But yeah, just an idea of what you can get in one day. Cool. Yeah, so once you have the skeleton rig done and you've done some motion on the bones, like before having a look at this, you sort of want to be happy that there's not too much intersection happening with the bones and everything looks like it's moving right. Then you can kind of be sure that you've got your skeleton in the correct place. And that means you're kind of ready to start warping the muscles, I would say. So we can do that now. The process for the muscles is slightly different because we're going to use the bones to do the warp as well. We're going to use that as part of the influence. So I have this have this scene here. So we have select these. The two skeletons. And then we're also going to need the skin models as well. So I'll bring those in again. just going to call this skin in there. Okay. So now what you're going to end up with is, if I just hide this for now. Did that run the wrong way, I think. Or I just didn't put it. Oh, there was already one in there, I see. Okay, great. What you're going to end up with is you're going to end up with a collection of bones and the skin, and then you're going to combine them all together, and you're also going to do the same for the ones that you've warped. So you have the warped bones and then the skin as well. Now, the issue is that if you've been, changing around your warped skeleton and mirroring stuff and things like that, the order of the objects in your group might have changed. So the important thing is that when you combine the two objects, they have to be in the same selection order. Otherwise, you can't get point correspondence. So you might want to make a little script for that. I could write one now. Might not have time. Yeah, basically it loops through your current selection, and because there's duplicates or whatever, you get the long name, and then you replace this part of the long name with that part, and then you can use something called, you can either use just regular poly unite, or there's also, if you have the ZIVA plugin loaded, we have a poly combiner as well. So if I select these objects, there's also the poly combine, and you get a new mesh. And because when you use poly unite, there's weird stuff happens with the history and things, right? So that's kind of annoying, and it's also slow. Yeah, so you can use poly combine, and you can do that with our stuff as well. Cool. So with the objects, sorry, these two here. You can see I've got the same setup here. So you have a from tissue, a from bone, and a to mesh. And there's already a blend shape between these two here. So scrub that, you can see. Hide this other stuff. Cool. So the idea now is to do what we did before. So we take the from tissue and convert that into a tissue. And then make the tet size smaller, turn off gravity, add a substep, and that looks good for now. And then convert the bone to a ZIVA bone. And then I can create my goal attachment. So for goal attachments, I think you have to have a tissue selected first. So ZIVA, select those first, and then ZIVA create goal attachment. And I'm going to leave it at default for now, just so you can get an idea of what you get out of the box with the default setting on that. I'm just going to add a cache as well so we can scrub the timeline. Okay, it doesn't look too noisy, but when we start embedding stuff, you might notice that that goal attachment ends up being a little bit too stiff. So that's kind of one of the attributes you can play with to get a different warp. But what we can do is embed this stuff now. Okay. So I'm going to select the tissue first, then all the objects that I want to embed. And then I had my script somewhere. Different my session. Okay. Why didn't that work? Okay, that's strange. Oh, I actually didn't call it, that's why. Bit multiple. Right. Cool. So you can see there's a bit of noise in the muscles. They're kind of a bit lumpy. So it does a good job, and it's respecting the bones and also the outer skin now. But that lumpiness is not so great. So there's a couple of strategies for this. Firstly, we can adjust the strength of that attachment, the goal attachment we made earlier. So it's 1 times 10 to the 8 at the moment. If I make it 1 times 10 to the 6, it's going to be weaker. It's also going to be less respectful of, firstly, the outer boundary, the skin, and also the bones. So chances of getting some intersections between objects at that point is going to be higher, but you are going to get less lumpy models. So let's just see what that looks like. I need to clear the cache. Should have done it before and after really, but yeah, you should be able to notice that those are a bit smoother now. Another thing you can do, oh, it didn't change, that's why. Do that again. Yeah, right, that's better. Another thing you can do is just put a delta mesh on everything, right? Because this is effectively still, this is modeling. So do this. And now it's starting to look closer to what a final muscle model would look like for a character of this fidelity. Yeah. So at this point, you know, I don't think I did for this guy. Where is he? I didn't do any hand work. So that the muscles that you see here are straight out of the warp. I didn't do any kind of hand cleanup or anything like that with these guys. So you'll notice that it's not perfect. So things like the bottom of the quads doesn't quite link up with the patella. And I think that is contributing to some issues in the solve. So you can see like, yeah, that doesn't look so good. But for the most part, I was pretty happy with how things came out of the warp. And when you are happy, then you can move on to copying the whole setup across from your existing character, your ZIVA setup, I mean. So we can do that now. That is doing a simulation. Okay, cool. So this is the Mr. Ink setup. This is the same one from the one that you can download from the free store. And so what I'm going to do is I'm going to capture this entire setup and I'm going to copy it onto our warped character. So if I bring up a script editor, first thing we're going to do is I'm going to select the solver. And then if we look at these lines one by one here, so this will only work if you have the ZBuilder library installed. You have to download it and put it in the script directory, or it might come standard now with ZIVA 1.4. But yeah, you have to have this properly installed for it to work. So this first line is going to bring in the builders.ziva library, and then we're going to create a ZIVA object. And within this object, we're going to populate it with the properties of everything we have selected and everything connected to it. So build the object first, and then we have to populate it. So we retrieve from scene selection. Because I have the solver selected, just going to grab everything. And I think it took about 18 seconds last time. And then the idea is that we will copy it, we'll read it in and copy it onto the other setup. So that's written, and then I think I have that scene lined up somewhere. It's going to open a new one. Warping. Post-warp. Cool. Great. So if I go back to Python editor, each object in here has a corresponding object from Mr. Ink. So, and everything has vertex correspondence. There's no, I mean, they differ spatially, obviously, but because all the vertex IDs are the same, the full setup should be rebuilt pretty much seamlessly. And also we've got the line of action curves in there as well. So all that should get reconnected straight out of the box. So again, we can import the library, create the object. This time we're going to retrieve it from a file rather than the scene or scene selection. And I did not write it to that path, I don't think. To that path. Let's paste that. Oh, I actually already had it up. Okay, yep. And then retrieve from file. It's going to take a few seconds to bring in. And then I can call z.build. And that we should get the output here of what that's going to do. And it's going to tell us if there's any errors as well. So you might get 1 or 2 warnings. There's something I have to inspect on the heel bone. And then I know what that is. The quads are missing they're not watertight volumes. So there's a hole in there that I need to fill. But it'll still build. You just won't be able to do bidirectional collisions with it. So it's going through the attachments. There's that heel bone again. Have to have a look at that. And I'm not on solver start frame. So that might break. Okay. So you can see it's all rebuilt. And then hopefully we can run the scene panel, which is a new feature in ZIVA 1.4. And you can check that things like the line of action built okay. And then if I right click, I can do select curve and it's found the corresponding curve, which is good. So yeah, it all comes in pretty much seamlessly. And then from there, you can import, to test it, you can import your Alembic cache of the bones. So I can do that now. What Alembic? And go scenes, warping, bones, Gus. Okay, and I'm going to give these a suffix. These are the driver suffix, so I can make blend shapes. So I've got this little routine here. I think I did this in a tutorial recently, actually. So it's going to take, this routine's called drive bones with blend shape. So it's going to take the list of objects that I have selected, basically, and it's going to look for the corresponding ZIVA bone. So it'll look for anything without the driver suffix because we tell it to here. And it's just going to, yeah, basically drive it over one frame at the start. Cool. And then then you can run your simulation, you can test it. I'm not going to do it now because it'd be too slow and people's time is valuable, but that's the process. At this point, we can take some questions, I think, and I could probably, there's some other stuff that I could show as well, some other parts that I did in the lead up to this, especially at the start, which I haven't shown yet, stuff with mesh mixer and things like that. But yeah.
Well, we haven't had any questions submitted just yet. I'm guessing people were pretty tuned in watching you do everything just now, though. So if anyone has questions about what they just saw, feel free to type it into the chat. Tristan says he has some questions, but not about anatomy warping. We can probably get to those afterwards. Okay. Let's see. No questions, anyone? Everyone just taking notes and understood all of that perfectly. That's good. That's
Everyone's
wonderful.
Just asleep.
Probably. Does anyone
it was that exciting. All right.
Tristan says that he needs to try it out, but doesn't have any questions yet.
Okay, cool.
I'm guessing some people will have to give it a go first, see how it works for them, figure out if there's any trouble points or areas of confusion. And maybe at the next live with ZIVA or in the community forum, you can always air your questions there. And I'm sure Andy would be happy to help.
That's great. All right, sweet. The idea with RAP3 is that it uses a routine called iterative closest point, and it's very good at projecting meshes onto each other. And you don't have to use this in order to get the results, but it's just an easy way of doing it. You can do it with Maya as well. You just can't, Maya doesn't have ICP. So you'll notice that these meshes have different topologies, and I can go back another step after this and how I got this topology, because this is not the same as Mr. Cave Troll here. You can see that he's got a face and stuff, right? And has also got a completely different topology. So we can go through how I got to this point as well. Once you load in your two geometries, then you create this select points node, again by hitting tab. For some reason, when you're using Zoom, you can't interact with RAP3, so I'm having that issue. And then when you have your select points node selected, you can go into the editor view, and then you can start clicking on the mesh. So you can see I've already defined the middle of the bottom part of the sternum, for instance, the knees. It's really important to get knees right, the front and the back. Things like the shoulder pivots, elbows, same as knees, important to get that stuff right. And then what that will mean is, as I mentioned at the start, when you do the warp with ZIVA VFX, it'll pull everything into the right place, because you don't want to have the bottom of the tricep way down here somewhere. It just you won't get a good result from when you start simulating, or you have to do more work by hand cleaning up the warp. So this process is about preemptively kind of avoiding that. So let's see if I can add a new point here. I can, that's cool. So just by clicking on the mesh, I get a number 20 here, and I can click again on the other side. And then that way you can sort of go through and establish. It's a bit difficult to see on this guy where the elbow actually should be. There. And then you probably want to do, I didn't do them all, but you probably want to go through and do the tips of the fingers as well. And then once you've done all that, you have to create a wrapping node. And then you connect your two mesh objects in the same order into the wrapping. On the left is the thing you're projecting, on the right is the thing you're projecting to, always in that order. And then there's a slot for the select points node as well. And then once you have that, you can hit compute and you get a little loading window. You can tumble it while it's doing its thing. So it does it in iterations. Just a really powerful tool because it does what it says it will do, and it's pretty quick. Cool. And then when that's finished, you create a new node called a save node, and then you have to export out the output of this wrapping node. And yeah, you can output it to an OBJ, and then you can bring that into Maya, and that's what we were looking at earlier. So it's just a fun way of doing that, and literally it only takes a few minutes to get it out, you know. So that's good. Are there any questions on that part?
We had Josh ask if you could adjust the points once you place them, but James already responded in the chat. He said yes.
Yep, you can. I could do one more thing with another software package, or if we want to keep it ZIVA specific, then we can do that as well. I'll leave it to you. Yeah,
go for it, Andy.
Cool. So this program is called Mesh Mixer, which you might have come across and it's kind of a good way to, it's really good at retopology in terms of if you want to paint resolution, you can do that. It's also quite good at filling holes. So, okay, so we've got the subject. The only thing with Mesh Mixer is that it forces you to work with triangles and it only outputs triangles. But that's okay, you can retopologize again in another software package. But you can see I cut off the nose and the ears and cut up the eyes and stuff because I don't need them for what we're trying to do. So if I come across here to select, and I can take the size right down, all the way down, something like that. And then if you double click on a triangle that has an edge on the boundary, it'll select those border edges. And then if you hit F, it'll do a fill. And it does a really nice job of filling holes. And you can even change stuff after the fact. So there's different types of fill. You can alter how much it bulges, the direction, scale. I think you can change the how many polys end up getting created with refine. Yeah, it's just a really nice way of doing this stuff, and it saves you having to do it all by hand. So we can accept that, and then clear the selection, go back to select, and do another one. Hit F, accept, clear selection. So you can see, it's done in no time. Yeah, so this is something I use all the time when I'm building models, especially ones that I need to make watertight, which we definitely want to do for transfers like this. So yeah, just thought it'd be worth sharing that with you guys while you're building characters, because we want you to get to the fun stuff, which is the simulation, as quickly as possible, right?